Imperial Beach experiences overtopping and flooding when energetic winter swell coincides with high tides. The video that you're looking at here is from an event in January 2019, which was a high tide that coincided with a large swell event. The frequency, duration, and severity of these events will increase with sea level rise, and the ability to predict them depends on the degree to which wave-driven run-up can be specified. An observing system and modeling effort have been developed to determine how uncertainties propagate through the estimate of total water level, or TWL. And there's many different moving parts to this puzzle. On the development side, we have long-running observations to make our model. We have 20 years of hindcast waves from the MOPS wave system, courtesy of CDIP, and 10 years of surf zone bathymetry data collected with our group from beach surveys with jet skis, ATVs, and push dollies. This information is fed into a phase resolving model, SWASH. But because phase resolving models can be computationally expensive, we develop an emulator based off the extremes, that is eroded beaches and large offshore waves. This is the IPA, or the Integrated Power Law Approximation, which takes into account the shape of the wave energy spectrum rather than the bulk parameters, which we have found to perform better than a tuned Stockton 2006 type of equation at this particular beach. The modeling study that created the IPA was validated with observations from the event shown on the first slide. Operationally, we use a beach slope model and MOP nowcasts, which ultimately derive from WaveWatch 3. And the tide and non-tidal residual are from NOAA, or the La Jolla Pier Gauge, which we found to not be that different from Imperial Beach itself. And those factor into the beach slope model and the total water levels in the final forecast. Each of these components does have uncertainty, and trying to understand how they all play together is part of the puzzle. What are the limiting factors to having skillful predictions? And what spatial resolution do you need to understand how flooding can be predicted along the Imperial Beach shoreline? In addition to the short-term flood forecasts, the information is being used to improve climate projections that quantify sea level rise impacts and provide a framework to assess adaptation strategies such as sand replenishment and berm construction, and give the inhabitants of Imperial Beach a better understanding of the combination of factors that lead to flooding and how these factors are likely to change in the future. Noting here that there was a recent nourishment in 2012. A bunch of sand was piled on this beach, but a lot of it did head south towards the Tijuana River mouth, which has potential implications for the health of the estuary system. Our goal with the Imperial Beach project is to collect all the information you could possibly need to address the coastal flooding issue, and then determine what subset of this information is needed to establish similar systems in other locations along the coast at substantially reduced cost and effort. The shoreline prediction system is going to, and has been, extending this strategy to state parks and beaches in California. So California coastal parks and beaches face the same challenges as Imperial Beach. Sea level rise will increase coastal flooding, groundwater inundation, beach and cliff loss, and shoreline retreat. And effective mitigation and planning requires monitoring and understanding coastal change as it unfolds. The California coastal park units need baselines to contextualize future change. And in the short term, timely high water level warnings, similar to those at Imperial Beach, are needed to prepare the facilities and the at-risk natural and cultural resources. In the longer term, we're working to develop the state-of-the-art observing systems and predictive tools needed to understand the coming risks and to develop cost-effective, proactive adaptation strategies.